We were dealing about how to find out the value of determinant, and later we learnt about the many properties of determinants and so on. So now we are going to learn what is the minors and cofactors. Yeah, minors and cofactors are related. There is some small difference between the minors and cofactors. So first of all, let us consider a determinant. So maybe a common simple determinant A, B, C, D, E, F, G, H, I. Okay. So what is considering minor? Minor should be considered only for one element of a determinant. So if you consider this is the determinant, say determinant of matrix A. So what will be the what will be the minor of A? Minor of A, I can consider A considering the small a. So minor of A, that is 1 1, first row, first column. Okay, 1 1. This is the representation for minor. This is representing minor. Okay. So I'm not just going to tell the definition over here. I'll just tell how you can apply minor and cofactor here. So minor of 1 1 is, so the definition says that what is the minor of an element is the determinant that is obtained by removing all the elements that is present in that particular row and that particular column. So if I consider this A over here, so there are one row, first row and first column considering that. So we need to delete all the elements that are present over there. So you are going to get that is E, F, H, I. That is all the elements that are not present in its row or column. Okay, that becomes the determinant. This value is called as the minor of A with respect to this. So let us take one more example. Maybe we'll take of this E, or I'll take F. Okay, minor of F, that is second row, third column. Okay, so what is the minor of this F is going to be is all the elements we need to remove that is related to its row and its column. Therefore we get A, B, G, H as the remaining thing. A, B, G, H. Okay, that's all about what is the minor. Minor was very simple, so there is nothing much extra. So we need to delete all the elements that are present in that particular row and column, and what is the determinant you are going to get at last is called as the minor of that element. That's all about minors. What is a cofactor? We represent a cofactor of a particular element by A. Okay, so first of all we have taken these two examples, right? Since we have taken these two examples, I'm going to take the cofactors of these two examples again over here because they are going to be like that. So what is the definition of a cofactor is, it is definition of a cofactor, maybe Aij I can write. It is minus 1 whole raised to I plus j to Mij. Okay, what does this cofactor tell? That is Aij, that is a cofactor for a particular element that is present in the ith row and jth column, is equal to minus 1 whole raised to I plus j into minor Mij, that is corresponding to that particular element. So what do I consider here? A11 is going to be minus 1 whole raised to 1 plus 1 into minor 1 1, or 1 plus 1 is 2. So minus 1 whole square is going to be 1. Therefore it is going to be equal. A11 is equal to M11. That's all about this one. So we'll consider the cofactor of this. Okay, cofactor of F, I'll consider there is the F element, that is A2 3. Okay, it is minus 1 whole raised to 2 plus 3 M2 3. Okay, so now again we are going to do this. 2 plus 3 is 5. So minus 1 whole raised to 5 is going to be minus 1 itself. So it is minus M23. Minus M23. So while expanding the determinant, we found out that while we expand using the second row, we used to take negative sign at this position and at this position, right? Also, while we are taking through the first row or the first column, at this position, that is the position of B, D, F and H, all those four positions we used to get we are asked to do one minus sign over there. Okay, that this is the reason why we use the minus sign. Okay, we'll just explain of how we find the determinant using this minus sign cofactors now. Okay, little more applications about minus and cofactors. Now, what is the use of learning this minus and cofactors? So, we are going to take one example based on this determinant itself. So, consider the determinant of A to be like this. So, we'll find the cofactor of each element. Maybe I'm trying to expand using the first row. Okay, if I'm trying to expand using the first row, it comes to be A into this determinant E, F, H, I. Okay, this is the determinant. I can just write it equal A into then minus B, because it was the second term. I use that rule somehow. So it is minus B into, that is D, F, G, I. D, F, G, I. Then plus C into D, E, G, H. D, E, G, H. Okay, this much we got. So first of all, what we are going to do here is we are going to connect this statement to cofactors, not minus, only cofactors. So we are considering A, B, C is here. Okay, they are considering to be the first row elements. Okay, so we are not going to touch them. These are the cofactors of this A. So this is a cofactor of A, this is a cofactor of B, and this is a cofactor of C. So we can take A outside here, and it is going to be minus 1 whole raised to 1 plus 1, because it is in the 1 1 position. So 1 plus 1 into this minor. Okay, this I can just consider to be minor, excluding this minus 1 thing. So it is going to be my M11, then plus B into minus 1 whole raised to 1 plus 2. That is first row, second column. That's why I am going to take this. So this minus sign comes to be included in this because it is minus 1 whole cube. And this is however the minor of this element 1, 2. Then again C, minus 1 whole raised to 1 plus 3, and the minor 1, 3. Okay, that's all about this. So if I unite this, and this, okay, what it is going to be? A into A 1 1 plus B into A 1 2 plus C into A 1 3. Okay. So this was the value of the determinant. Maybe I consider delta to be the value of the determinant. So if I consider delta, it is going to be like this. Or in general form, if I write A1, A11, A22, A like that, those terms, this becomes A11, this is A12, and this is A13. Therefore, the general form, that is the determinant of any matrix, is going to be A11 plus A12 capital A12 plus A13 capital A13. Okay, this is all what we learned and what was the required thing about cofactors. So directly if you find a cofactor and then multiply with that particular element and find the sum, maybe you can consider the row or consider the column. So there are 5 more cases, right? So maybe you can expand using the third row, third column, or anything, or the second one also. So there was no problem in this. So the value of the determinant come to be like this. So I might also think something new about this. So I have a wicked idea now. So maybe something, okay, we consider the cofactor of this. So maybe I'll consider the cofactor of something else. So maybe the value of A11, A21. Okay, I'm considering the cofactors of the elements that are present in the second row. And you have the sum, that is A12, A22 plus A13, A23. Okay, maybe I'll find the value of this. So maybe I'm going to get a property over here. That's why I'm going to use this. So A11, all these things we are going to do. So this is the cofactor of A21. So cofactor of A21, that is considering the D here, and A11. So maybe something, I'll expand it, right? How it is going to be? A into this is bi minus, and there is one minus sign also because it is going to be 2 plus 1. So minus 1 is over there, or I'll just rub that up once more. I'll write it is going to be a into minus 1 into 2 plus 1 is going to be minus 1. Then you have the minor of that 2 1, it is going to be bi minus ch, bi minus ch. Okay, then you have a1 2 is b. Okay, then minus 1 whole raised to 2 plus 2. 2 plus 2 is 4, so minus 1 whole square only, so it is going to be 1 itself. Then you have the minor of 2 2. What is the minor of 2 2 is ai minus gc, ai minus gc. Okay, then you have one more term, that is c. Then minus 1 whole raised to 2 plus 3. 2 plus 3 is 5, so 1 minus sign is going to be remaining over there. Then you have the minor of 2 3. What is the minor of 2 3? You are considering is ah minus gb, ah minus gb. Okay, we'll just now expand, and what we are going to get, we'll just see. So maybe a simpler term, minus aib, minus of minus is plus, then ach. Okay, then you have plus aib minus bgc. Okay, now we have minus ach, and one minus here, then minus of minus is plus. Now it is going to be bgc, okay, cut, all cut, going to be 0. So what is the property? So if you multiply an element, or the rows, the elements present in a particular row or a column with the cofactors of the elements present in some other row or some other column, then it is going to be 0. Okay, so we need to take care that you are considering a row and row only. You are not considering the elements of a row and then the cofactors of a column. So we need to consider a row only. Only in such a case we are going to get the value to be 0. So this is the property over here, that is the element multiplied by the cofactor of a particular row or a column, their sum is going to be 0. That's all about minus and cofactors. Now we'll move on to the exercise and find out what is new. Okay, now we have exercise 4.4 here. The first question, first subdivision. The second subdivision is very easy, I think. So it's all about general things. So if you do the first subdivision, you can understand what to do for the second one also. So we are asked to find minus and the cofactors of the elements in the determinant in the first and the second one. So the first question here is finding the minor of 1 1, minor of 1 2, minor of 2 1, minor of 2 2. Okay, so the thing is directly, since it is a smaller one, we need to just take only one element that is going to be there over here. So if I consider 1 1, that is all the first row and the first column elements are going, so only the element that is present is 3 over there. So you are going to get 3. So M1 2. So since it is simply a 2 by 2 determinant, I can just tell that the opposite element in that particular square is going to be the minor of that. So I can, if it is 1 2 here, that is first row second column, 0 is going to be its minor. Similarly, if it is 2 1, it is going to be minus 4, and here it is going to be 2. Okay, we need to just think more for cofactors than for minors. Minus is just about the elements over here. So since it is 1 and 1, so I plus j is going to be 2, that is even. Therefore minus 1 whole square is 1 itself. Therefore m11 is similar, and it is going to be a11 here also. So since it is minus 1 plus 2, it is going to be 3. So minus 1 whole raised to 3 comes in the power of minus 1 over there. So what is going to be here is, since a minus 0 is same as 0, I can tell that it is also equal to a12. Okay, next you have m22 2 plus 2 is 4, minus 1 whole raised to 4 is 1, therefore the minor is going to be equal to its cofactor, therefore it is equal to a22. The only special case arises here is m21. So what is a21? a21 is minus 1 whole raised to 2 plus 1 into m21. Okay, m21 was minus 4 and minus 1 whole raised to 3 is going to be minus 1. Minus 1 minus is going to be plus. Therefore it is minus m21 or 4 I can write. Okay, this is all about the first subdivision. Second subdivision they are given like that only. So extra thing there is all about this minus 1 in this case also. Since here it was 0, we just left it and just told that it is going to be equal. While in the second subdivision there is all variables, therefore one minus sign also gets included. So in the second question we have the first subdivision is a simple one, so I am not going to do that. It's just direct. Okay. Next one is the second subdivision. So we'll see what we are going to do for the second subdivision. So maybe we'll find the minors first, that is m11, m12, m13, then m21, m22, m23, then m31, m32, m33. Okay, 9 minors we are going to get. So it's all direct. That is not so difficult anything. Okay. So what we are going to do with m11? We are going to remove this. It's going to be the determinant, this part, that is 5 minus 1, 1, 2. Okay, that's all we are going to get. That is going to be 5 into 2 is 10. 10 minus of minus 1. 10 minus of minus 1 is 11. So you're going to get 11 here. Okay, next is 1, 2. M12 corresponding to this. Therefore, these elements we are going to remove. So 3, 0 minus 1, 2 remains. It's going to be 3 into 2. That is 6 minus 0. That is same as 6 only. Okay. Then you have M13. M13 corresponding to this element. Therefore, you get 3, 0 and 5 minus 1 here. So it is 3 minus 0. That is going to be 3. Okay. Then you have M21. That is corresponding to this element. Therefore, you are going to get 0, 4, 1, 2. 0 into 2 is 0 minus 4. It is minus 4 here. Okay. Then you have M22, that is corresponding to this. You are going to get 1, 4, 0, 2, or simply you are going to get 2 as a value. Similarly, we are going to do the remaining things. So we get 1 here. M31 we are going to get 20 minus 20 here. Then you have M32, we are going to get minus 1 minus 12, that is minus 13. Then you have M33. M33 is 5. So we'll just... The next part is all about finding the cofactors. So we need to take care that while we are going to expand any particular determinant, we used to take negative values at these particular 4 places. That is the thing that is not present on its diagonal. Okay, if you consider a square, the elements that are not present in the particular diagonal, only such elements we are going to take. Okay. So therefore it is going to be like all these elements are going to be the same. Okay, we'll take the alternate elements here. See the alternate elements 1, 2, 3, 4, 5. Yeah, these 5 elements, because 1 plus 1 is even, 1 plus 3, 2 plus 2, 3 plus 1 and 3 plus 3. They are going to be even. Therefore, they are going to be corresponding cofactors. A13, A22, A31 and A33. Okay, it's going down. Okay, A33. That's all about this. So just for these things, we are going to change the sign and write the same thing. Okay, we are going to change the sign and write the same thing. So what it is going to be here is A12 is minus 6. Okay, then a21 is 4, then a23 is minus 1, and a32 is 13. This is all about finding cofactors. See, directly we could find out just by seeing this, adding these two. If it was even, we directly wrote it is going to be the equal to the cofactors. While in this case, we are going to just change the sign and write, because the sum was going to be odd. Therefore, minus 1 whole raised to I plus j. I plus j was odd, therefore it is going to be minus 1 only over there. So we need to change the sign here, and we need not change the sign when it is corresponding to be even number. That's all about the second question. Next we'll move on to the third and fourth question. Okay, now we have this question. In this we are asked to find the cofactors of the elements of the second row and then evaluate the determinant. So our property we used that we need to multiply the element with its cofactor and find the sum. So they are asked corresponding to the second row, so we are going to use the second row over here. So what we are going to get here? So first of all, we find the cofactors, that is a21, a22 and a23. Okay, this was the property, right? We need to multiply that particular element with that cofactor. So we are going to consider this one, that is this 2. Therefore it is 3, 3, 2, 8. That is what we are going to get. Since it is 2 plus 1 is odd, we are going to get a negative sign first of all. Okay, then we have 3 into 3 is 9, then 2 into 8 is 16. 9 minus 16 is minus 7. So it is going to be 7 here. Okay, then you have a22. So since 2 plus 2 is even, minus 1 whole raised to 2 plus 2 is, that is 1 itself. Therefore one positive sign comes over here. So I am not going to get bothered about that. Okay, now we have 5 and 3, that is 15 minus 8. 15 minus 8 is again 7. Now we have a23. a23 is going to be 5 into 2 is 10. 10 minus 3, 7. Okay, we forgot to take the minus sign here. So 2 plus 3 was 5. So minus 1 whole raised to 5 is also minus 1. Therefore one minus sign appears here. That's all about this finding cofactors. So what is the determinant value of this particular determinant? Is going to be a21 plus a22 into a22 plus a23 into a23. Okay, so what was a21? That is 2. This is 7. Okay, then this is 0 into 7 plus 1 into minus 7. Therefore 2 into 7 minus 7 is going to be 7 only. The value of this particular determinant is 7. So instead of doing all these things, directly find out what in the question it is given. You need to find the cofactors and then find out the value of this particular determinant using this particular property. That's all about this question. Similarly, we can do the fourth question also now. Okay, now we have a fourth question. Here already have found out the cofactors. It was given you need to find the cofactors of the third column and then find the value of the determinant. So since it is going to be a variable, we need to always get the more simplified form for this. So maybe we are going to get some factors. So in order to get the factors, we need to work hard now. So what is the value of this determinant is going to be is yz into z minus y. Okay, then plus xz into x minus z. Okay, then you have xy into y minus x. Okay, that's all we got here. So we'll just expand. It's going to be yz square minus minus y square z plus x square z minus xz square plus xy square minus x square y. Okay, so out of these three factors, maybe one factor I can take out. So for that, maybe I'll just unite these two terms here, these two terms, so that I get some x minus y or y minus x. Anything is okay for me. So z square terms I'll just unite. This z square term. So nothing to do for these two terms, right? So for that, we have new thing. That is, we need to add, since it is negative sign here, I'll add xyz for this. And since it is positive sign here, I'll subtract xyz for this. Okay, corresponding to this. Okay. So first of all, we'll take this side. So maybe z square I'm taking out to be common. If I take z square to be common, what is remaining is y minus x. Y minus x. This was the first one. Okay. This was the second one. The second one was y square z plus xyz. That is, yz is common plus yz is common. What is remaining is x minus 1. X minus y is remaining over here. Then you have x square z and minus xyz. So xz is common over there. So we'll take xz outside. What is remaining here is again x minus y. X minus y. Okay. This was directly fourth one. Same thing. It was xy into y minus x. Okay. That's all about this. So we got some x minus y or y minus x term. So first we'll take x minus y outside. If I take x minus y outside, what is remaining inside is minus z square plus yz plus xz minus xy. Okay, this is all what we are going to get here. So what is the remaining thing? Maybe we need to get some more simplified term for this. So everywhere we are going to get x and z. So we'll do one thing. We'll take z common from here and x common from here. Maybe something else we are going to get here. So what is it here? X minus y is already there. Then you have z. I'll take common from this. It is going to be minus z plus y. Okay. Then plus x into z minus y. Or if I take one negative sign outside from here, this is going to be plus and this goes to be minus. So z minus y. So this is x minus y and z minus y is going to be common. Z minus y and x minus z. This is all about the simplified, more simplified answer. If you do until this, we are going to get the full marks. If you stop it here, we are going to get 1 or 2 marks less. So this is the importance of doing this. That's all about. So the extra thing which we have to do here is adding and subtracting one x, y, z such that we get one x minus y as a common factor. Maybe we could do some other factor also, need not be x minus y only. I saw x minus y which was more compatible for me, so I just chose that. And maybe if you get y minus z x, there's no problem because we are going to take one minus sign outside and then do the further simplification. That's all about the fourth question. The fifth question is all about the MCQ question. So let us read what is the MCQ question here. The question given is, so corresponding a particular determinant, it is given as a general determinant over there. So what is given over there is, which one of the following is equal to the determinant. So we know that for a particular thing to be the determinant, it should be A of a particular, maybe ij into ij plus the corresponding row or column. All the terms that come to a particular row or a column. Here it is given about a 3 by 3 determinant. Therefore, so we'll just check out the first element of each option. If you check out the first element in option, if it has to be equal, only if this and this is equal, this can be equal to the particular determinant. So we'll take only the first term, that is A11, A31 is given as the first element here. So this is not corresponding to this element. So this cannot be the determinant. Next we have A11 into A11. Okay, maybe that is correct. We'll take for the second term now. The second term says A12 into A21. Okay, so this is not the corresponding cofactor. Therefore, this also cannot be the particular thing. So next we'll go to C. C says A21 into A11. Can this be possible? No, that's not at all possible. Then you have A11 into A11. So all these three are wrong, however this is correct. So it is going to be correct, that is A21 into A21 plus A31 into A31. This is going to be the correct answer. That's all about the minus and cofactors. So now we are going to apply these minus and cofactors to find out the adjoint of a matrix and the inverse of a matrix from the adjoint and so on. So what we are going to do in the next part is, when we find the inverse of a matrix, we can also find out the values of a particular, maybe if you're considering x, y, z as one matrix. So if you're finding the unknowns, in such a case also this minus and cofactors, and further the inverse of the matrix is going to be useful.